Hello, everyone. Today we are talking about HVDC transmission and DC-DC converts. We introduce ourselves, my partner Andres Pinto, and myself, Paula Salazar. First of all, we need to know about HVDC and what that means. HVDC is high voltage direct current, and it uses in power system with DC in transmission of power over long distance. HVDC is less expensive than AC transmission. We base it on a paper called Voltage Source Convert, based HVDC transmission, and you can find the link below in the description. So let's start.
Okay, we are going to continue to the introduction to the HVDC. Actually, in this country, Colombia, we use AC to AC converters and as a transformers. All electricity is AC lines. This stage needs a substation because the lines are long. We know that a short wire has a negligible resistance, but in this case we have a long distance and the resistance reduces the amplitude, the AC amplitude. And for this case, use a transform when the energy come home. The chargers, TVs, PCs, laptops, and all systems use a DC current. Then those the instruments have a AC to DC converters. The HVDC idea employs a DC line. Actually, is a expensive tech, but the study of this contemplate a low cost because these lines wouldn't use a substation like a AC current. And this technology doesn't need these converters, the transforms. And we would finally use alternative energy plants and like a solar panel, wind turbine, etc. Continue. Okay, we are continuing to characteristics to HVDC transmission. Um, this transmission using a voltage source converters, and this name is VSCC, with a pulse width modulation PWM. This VCC is a force commutated with an insulated gate bipolar transition transistor AGBT and solid dielectrics. The HVDC cables are so long, and also the transmission and use thyristor valves, and in this case use a strong synchronous voltage in order to commutate. Some elements for this is a EGBT and thyristors. The EGBT is a transistor, insulated gate bipolar is his name, and is a control switch for power electronics, and is a union to FET transistor and bipolar transistor. And the thyristors is a union to PNP-N materials, and they have a similar function to diode, but the difference is that need a pulse to conduct to the current.
So now we are going to talk about applications. Having all the attributes of VSC based HVDC transmissions make it especially suitable in certain applications. So first of all, we have some applications that we can use in the industry. So first, we have underground cable. HVDC cable systems are used for their economic facilities and their installations without as many limitations. These cables do not suffer from distance losses facilitates some long voltage runs. This is due to the materials of cables being structured, being lighter and more flexible and easy to splice. Being structured cables help underground distribution, reducing cost. The another one that we have is power supply to insulate load. Forced communication dynamic voltage control and black start compatibility allow VSC HVDC transmission to serve instant loads and extend over long distance submarine cables without any needs to running expensive load generation. The another one that we have is offshore. That means the VSC transmission is compact with facilities that with feeding of loads from a distance in the case on the high seas producing energy from the shore, avoiding emissions. The other that we have is asynchronous interconnection. The asynchronous interconnection with the VSC system improve power transfer without current and power restrictions. That also helps to they don't have minimum power and current registration in any of them. And the last one that we have is multi-terminal systems. The VSC HVDC transmission reserve power through the reservoirs of current directions rather than polarity. This makes it easier to reserve power or intermediate independent of main the other voltage in all the system that we are going to do work. Okay. The next one that we're going to talk is the station configuration. So the system has especially configuration and all is based in that kind of circuit that we can see in this moment in the image. So HVDC transmission system based on VSC converted technology. The circuit is working with two bipolar HVDC system with converts connected to pole that we have in the extreme of each photo. So they have AC transformers, breakers, disconnected each other, and they produce the voltage source. The DC capacitors are grounded, and the electrical center point to establish the earth of reference in all the circuits. So also we have the converse valves that is almost in the middle, and we normally use the three phases, just to one and to three phases that we are going to use in the process about all of them. So now we can see the system in a block diagram and is composed in kind of six parts. First of all is the with the power transformer. The transformer, like I said some seconds ago, so it's ordinary single or a three phases power transformer with a low to top charger. The secondary voltage is that the filter bus voltage can be controlled with the top center to achieve the maximum active and reactive power. So in this system, we also use a lot of active and reactive power in all the process that is working and going to give some energy and about all the process. So secondly, we have the convert raptors that they are in the middle of the image that connected to the enclosure. So they are working to install it in series to each phases. So that key is composing voltage source converted to permit continuous and independent control of active and reactive power. Normally, the uses for this part is to provide low pass filter of PWM, partly to give the desired fundamental frequency voltage. Another one is to provide active and reactive control power, the fundamental frequency voltage across the raptor, define the power flow. And the last one is to limit the short circuits currents. Also, we have an important part that it's all the DC capacitors that we have around the system and the circuit, that the primary objective of the value DC side capacitors is to provide a lot of inductance. Also, they help to reduce the harmonic ripple and directed voltage. Secondly, we have the AC filters. So, like we know, we have some harmonic ripples, so we have to use some filters to reduce all of them. And we are going to use a HVAC filter and DC filters, both out to help to reduce our harmonic voltage and all the current that it's going to be in a low part. Also, like I was saying, so we are going to work a lot with high frequency. So the voltage convert the necessary high dB slash DT in switching of values means that need high frequency noises generation is significantly higher than the conventional HVDC converter. And finally, we are going to have IGBT values. So they are gate bipolar transistors. So you see in VSC converters a compromise of series connected to LGT positions. Normally, they are like every device's activation, the forward drop of bipolar transistors as conducting device. So
Okay.
now,
We are going to start to converter control. The equation illustrates that the power can be controlled by changing phase angle alpha. When alpha is 0, we have a 100 power supply. And whereas reactive power can be controlled by changing magnitude of converted voltage with respect to filtered bus voltage. In the next, we have a circuit to voltage source converter. This is for AC converters, and VCC HVDC. This is a voltage supply or voltage source for this stage. Uh, we are gonna talk about to PWM. We can change the
ah, sorry.
and for this chapter, we're talking about two harmonic generation, and we try to cancel this for PWM. This part enabled independent control. Is forget reactive power at a constant voltage. PWM create a sinusoidal voltage like this, and we can minimize the harmonics. And um, that's all for this.
That's all, yes. So normally the PWM that we are going to use in that kind of system, it uses to um, give some pulse to reduce all the harmonics, like my partner said. So this is all. Thank you guys,
Like
and see you soon. Bye bye.